Project 2.6.2, Real-Time Clock, RTC Prototype, by Atticus Stiplady. This project aims to create a functioning clock capable of displaying the time on a COM 09481 4-digit 7-segment display. This project also built upon the previous project, Project 2.6.1, by incorporating the clock created on a breakout board. Instead of incorporating an Arduino Nano with this project, the AT-Tiny85 is used. The AT-Tiny85 chip is a low-power, high-performance 8-bit microchip with many beneficial properties, such as an 8 KB flash memory and 32 general-purpose working registers. The AT-Tiny85 IC is first connected to a 74HC595 and the real-time clock created in the previous project. The clock is what gets the circuit to update every minute and keep counting even if disconnected. The first shift register is what the Tiny85 is connected to, which is then connected into a second. The two shift registers are critical to this project as they drive the display. The first 74HC595 is incorporated as each of its outputs, apart from the first one, is wired to the display through a resistor. The second 74HC595 sets each digit as separate so the code can access each digit. The second shift register incorporates its last four outputs and connects each one to the four 3906 transistors. The collector pin of each transistor is then connected to the display. The combination of the Tiny85, two shift registers, and 3906 transistors is what allows the code to access each digit and display the time or a sequence of different numbers. Furthermore, the display, the COM 09481 4-digit 7-segment display, is what allows the time to be displayed using persistence of vision. Looking at a regular 7-segment display, you can see that it needs 10 pins in total to function properly. Since the COM 09481 display only has 16 pins and not 40, it requires code to function. On the far right of this diagram, the top segment of the display is labeled A, meaning that input A controls that specific segment for that digit as well as the other three. The same thing goes for the other 6 digits. The code for this project is simple but long, so bear with me. The code begins by defining each pin and time intervals, such as how long the clock is on compared to when it is off. Following the declaration of each defined statement, the code then creates a few global variables, such as defining each timestamp, seconds, minutes, hours, etc. The code then declares each number in an array for the display to find it. Starting at 0, and as you make your way around the display, each segment on or off is represented by 1 or 0. The code is followed by the setup and loops functions, which gets the code ready to launch by setting up key commands such as the library and continuously updating the time. The two following functions are created to obtain the date and then set it so it is ready to be displayed. The buffer is another crucial element that is new to this project. A buffer is very similar to an array in which it can store variables and save data. In order to display the hours and minutes, each buffer is set to either the tens or ones digit of the hours and minutes by dividing the hours by 10 to get the tens digit and the remainder being the ones digit. The clock can access your computer's time through the _time_ macro. The _time_ is a predefined macro delivered in a string sequence and it is collected from your computer using the scanf function. The date can also be obtained using the _date_ macro. There are some extensions to the primary clock, such as including a potentiometer to adjust the brightness of each display manually and an LED that turns off when it is PM on a 12-hour clock. It is able to turn on and off the LED thanks to the various lines of if statements in the getTime function. Thank you for taking the time to watch my video on the real-time clock.